Hello and welcome to the PsTools party here at the Sysinternals 25th Anniversary Festival. I'm Aaron Margosis, Global Techno Ninja at Tanium. And yes, that's my name on the cover of the book. It's there because Mark needed a co-author to help bring this book to life. He didn't have time to write it all by himself. And as a longtime user of the tools, I needed this book to exist. In fact, I've reread a few chapters in preparation for this event. This session is about the PsTools, a set of Sysinternals utilities that share some characteristics in common. Specifically, they're all console utilities, command line utilities, meaning you can use them in batch files and scripts. They write their results to standard output or standard error, where you can redirect them to files, unlike graphical GUI tools. Also, the PsTools, for the most part, can operate on the local computer or one or more remote computers. And there's a consistent syntax among all the tools for how to specify remote computers as well as alternate credentials to log on using a different account to connect to the remote machine. One of the tools, however, is not like the other ones. PsPing is a comparatively new Sysinternals tool for network diagnostics. It's included in the PsTools zip download, but it's so different that it's not even in the same chapter in the book. So here are the tools. Here's the full set of the PsTools. They serve a variety of purposes. To be fair, some of these tools aren't as useful today as they were when they were first written. With the exception of PsPing, they all come from a time when Windows was still focused on its graphical interfaces and offered very little in the way of scriptable management, and long before PowerShell was even conceived. But some of these tools still offer features not found elsewhere. I'll demo some of them, including some that I still use all the time. Let's start with these three utilities. We'll start with PsGetSid. A SID, a security identifier, identifies a user, a group, a computer in Windows. All these items have a SID, and there's a translation between that and a name. For example, the SID for the administrators group on a US English system is S1532544. So with PsGetSid, you give it either a name or a SID, and it'll reverse it and give you the other thing. Now, in this case, S1532544, this is what actually identifies the administrators group. Under the covers, Windows does not use names. It uses SIDs, the security identifiers, to identify things. This is a US English system. Let's have a look at a French system. Here's a French system, and we'll bring up PowerShell and run that same command, PsGetSid. And no banner is, if I don't do no banner, it gives you copyright information. So here, I'll do it both ways. So no banner gets rid of this copyright stuff and just gives you the data you're looking for. But you see here, S1532544 on a French system is not administrators, it's localized. Also, may not know this, but NT authority is localized as well. Here is the SID for the local service account, and on a French system, it's this. I'm not going to mangle French, but this is not the same as it is on a US English system, as you can see. Another interesting thing you can do with PsGetSid is get SIDs. Not all SIDs are defined on all systems. So for example, 549, this is on the Windows 10 system, it's not defined. However, these SIDs are defined on domain controllers. So what we can do is, using the syntax to operate on a remote computer, we can query a domain controller. In this case, this is my domain controller, have it do the translation, and we see that it is, in fact, the server operator's SID. And let's have a little bit more fun with PowerShell and look at a series of these things, 548 through 550, and we see none of these are defined on the local system, but if I run a command against domain controller, it's account operators, server operators, and print operators. Now, why is this useful? Well, you're going to run into SIDs all the time, and getting the translation, you can do it in PowerShell, but it's a rather long, complex command. I've never memorized it. PsGetSid is way more convenient for me. I use PsGetSid quite often. Here's another example. If you run PsGetSid without any parameters, it will give you the SID of the local computer. So all local accounts and groups, locally defined groups other than the built-in standard groups, are all going to be based on the machine SID. So if I do PsGetSid, and that SID, of course, is just going to give me back the computer again, the -500 account is the administrator account, might be renamed. In this case, it's not. Let's do the same thing on the French system. Add the -500, and you'll see it's also not renamed here, but it is localized. So on a French system, the -500 account is not called administrator. This can be very important to note. So it's tremendously useful for this kind of getting the SID when you need the SID, getting the name when you have the SID. So that's PsGetSid. The next tool I want to talk about is PsSuspend. And what this tool does is it, as you would suspect, suspends processes on a local or remote NT system. Obviously, this code was written a long, long time ago. It works perfectly fine on all modern Windows systems, but let's have a look at how this can be useful. Let's first of all run something that is going to need to be suspended. We'll run a couple of them. This is a test app, and this one's going to have one thread running continually, and this one will have two threads. And let's look at Process Explorer. Let's hide all these, everything launched by WinInit. And here's virtmem test. And you can see here, one of them is consuming almost 50% of this 4 CPU system, one of them 25%. You see the CPU usage has gone way up. Now, if you have a system and you've got code running, I could kill these processes, but if they're doing useful tasks, I don't want to kill them. However, I could use PsSuspend to pause them for a little while, and I specify either a process ID or a name. I'll do virtmem test, and it'll find all instances of virtmem test and pause them. You can see here they're running, and now they are suspended. And Process Explorer shows in gray that they're suspended. If you go in and look at the Threads tab, you'll see that the suspend count for each of these threads is now 1, and these things are not running. Now I can, with the system not bogged down anymore, you can see the CPU's gone way down, I can do whatever I need to do, then come back and use -R with PsSuspend and allow them to continue doing their work. There's another use case for PsSuspend, and that is if you have malware running on a machine and you kill the process and it comes right back. What that typically means is you've got malware operating in a buddy system where you've got 2 or more instances of these processes monitoring one another and watching for one another. And when one of them is terminated, the one that's still alive will start a new instance of that process. And so killing them won't work because you need to kill them very, very quickly in order for the buddy not to, I mean, if the buddy is running at very high priority, it's going to be really hard to kill all of them in time before they start up new instances. So what you can do instead is to suspend them, because I've yet to hear of an instance of this malware that will watch for something being suspended rather than being terminated. So now they're suspended, and now you can go in and kill them. And if you've ever seen Mark do Case of The Unexplained and talk about how to put them to sleep before killing them because it's more humane, he always loved telling that one. The tool to use here, if it's a Sysinternals tool, is PsKill. PsKill allows you to terminate processes either locally or on a remote computer. Obviously, you need to be admin on a remote computer to do that, or have admin credentials. Specify process ID or name. And with the -T option, you can also kill any descendant processes, any child processes belonging that were started by it. PsKill virtmem test, and they're gone. So next, everybody's favorite tool, or one of the most popular of the PS tools, is PsExec. PsExec is a tool that allows you to run processes on remote computers or on the local computer in a different security context. Yeah, there are other ways of doing this kind of remoting now in Windows. You've got PowerShell remoting, for example. PsExec is still a rather useful tool for a number of different reasons. It is also, by the way, though, often flagged as malware. Let me switch back over to the slides for just a second. Here's the command line. And I do want to say PsExec is not malware. It does not exploit any vulnerabilities. It does not offer any unauthorized elevation of privilege. It doesn't even use any undocumented or unsupported interfaces. That said, it's a powerful tool, and therefore PsExec is often used by malware, but only as a post-exploitation tool. PsExec can do nothing to benefit the attacker unless the attacker already has control of an account with admin rights. PsExec, you can specify the remote computer. That's optional. You can operate on the local computer as well. Some of the best options, some of the favorite options are -S to run a process in the system account, to run something interactively. I'll demonstrate that. To run the WinLog on desktop, that's a fun one. I'll show you that. Very few real use cases for it, but it's fun. So we'll definitely do that here. So first of all, let's show you what happens when you run PsExec on a remote computer. Now this is the domain controller. I'm coming in as a member of domain admins, and I'm going to run command prompt on this computer. And let's see if we want to see that instance here. There it is. PsExec service launches cmd.exe. You know what? I'm going to run this as admin so we can see all the information. Right, so there's cmd.exe running in session 0 as the domain administrator. But you don't see anything showing up on the screen over here. It's over here. What's happening is it has launched cmd.exe, the command prompt, and is echoing text back and forth between the computers. So it's like a remote shell. So if I do host name, I'll see the host name of the target system. If I do who am I, it's the account I'm running as. ipconfig 20.11 is the client computer over here, not the one I'm running from. So I'm running this remote shell as domain admin, which is the account I was running as over here. If I exit out, you'll see those processes go away on the remote. Let's do that again, and this time specify -S. I'm going to run as local system now. And you see here that cmd.exe is now running as local system on the remote computer. Another fun thing to do, though, is to run something interactively on the remote computer. Most of the things here are running in, this desktop is running in session number 2. So if I specify -I2, that says run it in interactive session number 2 on the remote computer, and let's not wait for it to return. So -D says don't wait. I'm now running this command prompt in an interactive session as local system. That can be a fun trick. So these are things you can use. So you can run all kinds of remote things and perform remote operations within PsExec. What I most often use PsExec for is when I'm running on, I'm doing troubleshooting on a machine, I'm running as with an administrative account, running elevated. I want to run something as local system. I can run PsExec and just run directly on the local computer. So I'm now doing a remote to the local computer. Here again, this is running in session 0, non-interactive, and echoing the text back and forth. By the way, if I try to do something like clear screen, it's not going to work because it's running in a different context. It has no idea about what window this is actually running in. What I can do instead, and what I do sometimes, is run interactively in the current context and also don't wait, PsExec-SID, CMD, or PowerShell, and I've got stuff running as local system. This can be really, really useful when you're doing advanced troubleshooting and you need to look in areas that the administrative account can't look at. So for example, I can go into system volume information and poke around if I need to. I can also go into the registry and go into the local SAM, other areas of the registry that are typically available only to the system account. Have a look at permissions here. Administrators has practically nothing. Has permissions, has the ability to modify the permissions. Don't do that, by the way. Never, ever do that. System has full control. Better to run something as local system and not mess with the permissions. This is tremendously useful. So the next thing I want to show is a cool trick. And for this, I need to go into the console session and run from there. Because what I'm going to do now, by the way, where am I running? I am still in session 2. Okay, we'll see. PsExec, I want to run something on the WinLogon desktop. I need to run a system, so -S. WinLogon desktop uses the X switch, and then D says don't wait for it to return. Interactive session 2, and we'll run cmd.exe. Okay, so now I am running, where is it? Oh, it doesn't have a parent process because I didn't wait for it to exit, so it doesn't have a parent process anymore, but here it is, running as local system in session 2. And if I look at the handles, actually it's not going to show the desktop handles, but where is it? Where is this thing? Well, let's lock the computer. So lock, we're at the logon screen. Okay, Alt-Tab, there's a command prompt on the logon screen. This is the WinLogon desktop. Who am I? System. You have to be running a system to do anything here. I'll run this tool I wrote a while ago called TS Sessions and have a look at where exactly are we. We are in session 2 in the interactive Windows station on the WinLogon desktop. Why would you ever need to do this? If you're writing code that needs to run on the WinLogon desktop, like you're creating a logon provider or something like that, and you want to run your tools like Spy++ or something like that to verify what's happening on the desktop or to manipulate it directly, this is a trick you can use. That's the only valid reason I could ever come up with for running something on the WinLogon desktop, that and scaring the you-know-what out of people. And it timed out, so there we are. So exit this. Okay, that was fun. Let's have a look at the newest PsPing. So PsPing is a network diagnostic utility that offers standard ping capability using ICMP, the Internet Controlled Message Protocol, as well as doing other probably more useful network diagnostics. One of the advantages of PsPing over the regular ping is the higher resolution. Let's have a look at that right away. If I ping a machine and it responds, it's giving me the resolution in milliseconds. In the mid-90s, when this capability was first being invented or deployed, that was probably fine, but in 2021, it's not really as useful as what we could use. PsPing, with no other parameters, does basically the same thing as ping. It uses ICMP messages to measure how long it takes to get a response back. Using ICMP. A couple differences you see here. One is greater resolution, hundredths of milliseconds rather than just milliseconds. Another thing also is it'll do a warm-up before it starts counting the actual statistics to make sure that the software on the remote side is up and running, because you don't really care typically how long it takes for that to come up, especially if it makes the numbers take longer. Once it's at a steady state, that's when you want to start measuring. So you have the ability to add a -W option to say how many warm-up pings you want to do first. So here are 3 of them before it starts counting any of the actual statistics. Now, the thing is that ICMP works fine for the most part on your internal networks, but when you go out on the internet, it's typically going to be blocked. So if I do psping sysinternals.com, it's not going to respond. Sysinternals.com has a web server, but they're not going to respond to anybody just asking, hey, what are your ICMP statistics like? So what you really care about anyway is, can I connect to the web server, and how long does that take? The difference in the syntax between the regular ping and ICMP and the TCP ping connection latency is basically just add colon and a port number, and the rest of the syntax is basically the same. So Sysinternals is listening on port 443 for HTTPS. And that's what I care about. How long does it take to establish a TCP connection to that port and then tear it down? And that's the measure you get here. Additional things you can do, again, you can set a different number of warm-ups with -W. You can also say, don't wait 1 full second, just 0 interval between the connection attempts. You can also specify, hey, I'd like to do more than just 4. Let's do 8. Use -N to increase or change the number. And another really useful thing is to do a histogram. So what can we do with histograms? First of all, let's bump up the number and get 50 of these. And let's do -Q because all these intermediate results, we don't need to see all those. And we have latency going everywhere from 68.82 milliseconds up to 377.02 milliseconds, and a count of the number of results landing inside that bucket. So what can we do with that? Let's do that again, capture it to the clipboard, and we'll bring up Excel, paste those results in, and let's zoom in on this. Yeah, we've got one outlier, and so they're all in this one bucket here. Let's try another one just to see if we get some more interesting results. Those single outliers can mess up the bucketing. Here's a little more interesting. So we'll zoom in on this, and we can graph the results. Oftentimes you'll see something a little bit more like a bell, but in any case, this is fantastically useful functionality. So there's additional tests we can do that require that the server cooperate. So what we'd like to do is see how long does it take to upload or download data, and how much bandwidth can the server take. To do that, you need to have something on the remote computer that's listening and cooperating with you. And that's where PsPing has a server mode where you set up a listening instance of PsPing, and then your client can connect to that server. So here, -S for server mode, the interface you want to use, and the port, and then -F if you want to create a temporary firewall rule allowing connections into that port. So now it's listening, and we can see here that now PsPing is listening on port 1001. And if we have a look at the firewall rules, we'll see there is a Sysinternals PsPing rule temporarily created allowing connections in. So now we can do things from the client. We're going to send 1 meg at a time. We'll do that 100 times. And we can see it went from a minimum of 0.92 milliseconds to 7.45 for each of these instances, for 100 separate instances. We can also do histograms. We can ask it, okay, let's go the other direction, send the data from the server to the client with -R. How long does it take to send a meg 100 times and get the range of values for each of those? So I would love to show you how we can use UDP. We can measure UDP performance. Again, that requires the server to cooperate, because UDP being connectionless will not, it's kind of hard to measure UDP unless you have two sides cooperating really well as testing bandwidth. Anyway, thank you very much for your time. Enjoy the rest of the conference.
My greatest pleasure speaking with Mark at conferences such as Microsoft TechEd was after a session, and usually we have very large crowds, people would come up to the front, and I'd often receive thank yous for working on the Sysinternals tools. I gladly accepted credit, and that annoyed Mark to no end.